we are starting notes on distance, midpoint, and Pythagorean theorem. I'm going to do this in actually a different order, so if you guys can flip to the back for me, we're going to start with Pythagorean theorem. Okay, so the directions say find the missing side of each triangle, leave your answers in simplest radical form. So Pythagorean theorem, you do need to know, is a squared plus b squared equals c squared. Okay, your C side is the most important side, and it is always the longest side. It is the hypotenuse, and it is across from your right angle, so you can kind of view your little box as an arrow pointing you to which side is the C. Does not matter which one you make, A or B. I do not care. It doesn't faze me. It won't change anything in your problem. Okay, so in this one, our A is going to be the square root of 10 squared plus our B is the square root of 14 squared equals x squared. Then you just need to square each side. When you have a square and a square root, they cancel each other out, which is awesome. So this is just 10 plus 14 equals x squared. If they're on the same side, the equal sign, you add them. If they're on different sides, because you could be looking for A or B and know what C is, you would need to subtract. And so 10 plus 14 is 24, which equals x squared. And then to undo the square, you need to do the square root, which will give you the square root of 24. This you do need to simplify. So you've got to figure out which of your perfect squares goes into it. What's the highest perfect square that goes into it? So all those numbers. This one happens to be 4. Okay, because 6, only 2 and 3 go into, no more perfect squares. So these two numbers are what we're going to break this into. Square root of 4 times the square root of 6. The square root of 4 is 2. Can't do anything with this guy, so it stays the square root of 6. And that is your answer for the value of this length. Okay? The next one on here, the directions here say state if each triangle is acute, obtuse, or right. So we're not sure which is which. Okay, and we're going to use Pythagorean theorem, but we're just going to mix it up a little bit. We're going to do c squared. It's not equal to, I'm just going to put a big open circle here, and then a squared and b squared. So at the end of this, you'll see why I put c squared on this slide. The reason we put an open circle here is because we don't know if they're equal to each other or not, and that is what we're trying to figure out. So c still needs to be your longest side. So you need to figure out approximately what these guys are. This guy is approximately 16.03. So 6. This guy, if you just plug in your calculator and figure it out, is 15.52, because you do need the longest side to be your C. Okay, so C has to be the square root of 257. I know that in these pictures you can tell this one looks like where the right angle would go. But just be careful. You don't. It won't always necessarily be drawn to scale. Okay? And then A or B, it doesn't matter which one goes wherever. So this guy squared plus 3 squared plus the square root of 241 squared. Okay? So when we square these guys, that cancels it out. That just gives me 257 something. 3 squared is 9, and this guy squared is 241. Alright, so then we're just going to add these guys together, which gives us 250. And now you need to compare these two numbers. So which one is bigger? Are they equal? In this case, the number on the left is greater than. Okay, since it's greater than, this angle is an obtuse angle. Okay, so this makes this triangle. So because it's greater, than, this is an obtuse triangle. Okay, and that's exactly why we put the c squared here, because then the symbol makes sense. So if you got a less than sign, it would be acute. If they were equal to each other, it would be right angle, which hopefully makes sense. This number is greater, this length is longer, which would pull this angle into being a larger than 90-degree angle. I'm actually going to skip number 5. I want you to try it on your own. And I'm going to do the same thing with number 6. Okay, I want you to try these guys on your own, and then we will look at them together. Okay, so see if you can do it. You can pause the notes now, or you can do it at the end. Do not forget this. You will not get all your points if you do not do these problems. Okay, so let's sneak back and go to number 2. We are going to do number 2 first, and then we'll go into number 1. I know it's all crazy and out of order. So what I want you to do here, we are looking for 2 things. We're looking for the distance, and we are looking for the midpoint. Okay? Both of these have formulas. We will look at the formulas in number 1. With this example, I would like you to actually just use your brains and think. Okay? So distance-wise, we can turn this into a right triangle. Wow, that was really pretty. Is anybody impressed with my super not so straight line? Let's try again. So we've got a nice little right triangle here, right? So it's actually exactly what we just did with Pythagorean theorem, because this guy right here is just 1 unit. This guy is 1, 2, 3, 4, 5 units, and we're looking for this one. So you can just use Pythagorean theorem and solve this problem. Okay? So your C side will be here. Whatever you want will be A and B. So this is 1 squared plus 5 squared equals x squared. 1 squared is 1. 5 squared is 25. And x squared. Add these together to get 26. And square root to get x. This one actually does not simplify at all, so this is just your answer. That is the distance from here to here. Done and done. So if you like Pythagorean theorem, you can just use Pythagorean theorem for this. No big deal. When it comes to midpoint, we're finding the middle of this. So if you think about it, you know, we can sneak in 1 spot and 1 spot, sneak in 2 spots and 2 spots, and then this one would have to be in the middle here. So that's where our midpoint would be. And this is going to be 1.5. And on this line, halfway between here and here is 4.5. Guess what? That's it. That's your answer. That's the midpoint. 1.5, 4.5. Okay? If you are somebody who likes formulas, formulas are your friend, then you're going to like number 1. If this all makes sense to you, and you are handed a problem that looks like this, ask me for a graph paper. You can use scrap paper, you can plot the 2 points, you can make a triangle, and you're good to go. If not, totally fine. Let's do distance first. The formula for distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. This makes sense. This is Pythagorean theorem. Okay, let's just look at it real quick. Okay, you're taking the x values here and here and subtracting them. Subtracting them gives you the distance. Okay, there's your 5. Subtracting these would give you this distance. That would be this. You're squaring them because it's Pythagorean theorem. You're adding them together, right? Squaring them, adding them together, and then you square root it because it's equal to c squared. So to find what c by itself is, you would just square root the whole thing. So you can think through this. You will not be given this formula, so you need to find a way for it to make sense. The other thing that you really need to do, if you're not going to draw a picture of it and use Pythagorean theorem, is you need to label this. And please think about this. We've got x, y, because it's a coordinate, x, y, xy. It's not x1, x2, y1, y2. Coordinates are always x and then y. And then this guy is your first point, and this guy is your second point. That's why it's numbered that way. Okay? So label them, make sure it makes sense when you label them, stop doing crazy things. Okay, and then you're just substituting stuff in. Y2 is 4 minus Y1 is negative 8 squared plus Y2 is negative 3 minus Y2. Alright, and Y1 is negative 6 squared. Okay, and then you just kind of need to take your time with this. So I'm going to boop, boop. Subtracting a negative is the same as adding. So 4 plus 8 is 12 squared plus negative 3 plus 6 is 3 squared. Then we've got 12 squared is 144. 3 squared is 9. We add them together and we get 153. You do need to simplify this if possible. 153, 1 plus 5 is 6. 6 plus 3 is 9, so I know that this is divisible by 9, and it gives me 17. 17 is prime, so there is no other number to go into it. So we can do 9 times 17. Square root of 9 is 3. Can't do anything with 17. Boom, there's your answer. Okay? I know. It's kind of a whole thing. Okay? When it comes to midpoint, we were just finding the middle of these. When you're finding the middle of two numbers, what are you doing? You're averaging. So you're taking your x values, you're averaging them, there's 2 of them. You're taking your y values and averaging them, right? That's all you're doing. So I have negative 8 plus 4 divided by 2. And I have negative 6 plus negative 3 divided by 2. Negative 8 plus 4 is negative 4 divided by 2. Negative 6 plus negative 3 is negative 9 divided by 2. And then divide them if you can. Negative 4 divided by 2 is negative 2. And is that negative? It is negative. And this guy you can leave as negative 9 halves, or you can change it into negative 4.5. I do not care. Alright? So, think about it. It should make sense. Okay? And remember, if you don't like this way, if you like formulas, awesome. Use formulas every time. I don't care, because you can always just take the picture. You can figure out the coordinates here, and you can substitute them into the formulas. Awesome. If you don't like the formulas, grab some graph paper, plot the points, make a triangle. Okay? Whatever way works, I don't care. Whatever makes you happy. And see you later. Don't forget to try the other two.